Hey, welcome back. This is another edition of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 4.6 on arithmetic. You spell it, I know it looks like arithmetic, but as an adjective, we say arithmetic sequences. And we've done some of this kind of stuff before when we're dealing with linear functions, linear relationships. Let's move on here. Let's see how fast we can do this here. Leave that. Okay, so in an arithmetic sequence, we have this idea of common difference, and we've seen this already in constant rate of change. But the rate of change was always divided by the rate of change of the x value. In this one, we don't really have an x value so much as its position in the sequence. So the first one here is 5, the second one is 10, the third one is 15, fourth one is 20. We have a common difference here of 5. Now normally when we have the slope, we divide by the common difference of the difference in the x values. But here, it's always going to be a 1, because in the sequence, it's always just one followed by the other. So this is an arithmetic sequence, 5, 10, 15, 20, because each one has there's a common difference of 5 between each member of the sequence, arithmetic sequence. Okay, so what are we going to do with that? Extending an arithmetic sequence. So here's an easy example here. So from -7 to -14, that's a subtraction of 7. And then I'm subtracting 7 again to get to -21. And then subtracting 7 again to get to -28. So what are the next three terms? Well, that would be subtracting 7 again would be -35, and then -42, and then -49. Just that easy. Okay, so make sure you understand how to extend the arithmetic sequence. In example 2 here, we won't be doing much here, but if I graphed an arithmetic sequence, so see here the x values, the position in the sequence becomes the x value. Position 1, let me put them up here, 1, 2, 3, 4, those become essentially the x values. And if I graph these, what do we notice? They lie on a line, because essentially we have like this linear relationship. It's a linear function, isn't it? So there's not much to do here. I just want you to know that an arithmetic sequence, when graphed, results in a line. Let's take a look at this example. Does this graph represent an arithmetic sequence? Well, they're in a line. But if you're not sure, let's take a look at our differences here. 15 to 12, this would be a -3. 12 to 9, also a -3. 9 to 6, also a -3. So this will be an arithmetic sequence as well, right? So yes, explain. The points are in a line. I also have a common difference of -3 between each of these y values. Okay. We'll do that in class. This is really what I need you to take away from today's lesson, that if we want to write an equation for the arithmetic sequence, for any term, the nth term, will let a sub n be the nth term? Well, we start with the first term and we add to that the n minus 1, so the previous position, time d, that common difference. Okay? So make sure you know this one as well. Let's try one here, I think. All right. So here I have this arithmetic sequence, 14, 11, 8, and 5. And we want to write an equation for the nth term. So let me put this back in here. A sub n is equal to a sub 1 plus n minus 1 times the common difference of d. And then we're going to find the 50th one. Okay, so a sub n is equal to, what's a sub 1? That's the first one, 14, plus n minus 1. And our common difference here is what? Oops. Negative 3, right? We're subtracting 3 times negative 3. And I can distribute on the right side, 14 plus. Negative 3 times n would be negative 3n. And negative 3 times negative 1 would be positive 3. Okay, so then 14 plus 3 would be 17. So a sub n equals, I'm going to put that in the order that we're comfortable with, negative 3 times n plus 17. And this is our equation for the nth term. Now, if I want to find the value of a50, a sub 50, a sub 50 is equal to negative 3 times 50 plus 17. So a sub 50 is equal to negative 150 plus 17. So a sub 50 is equal to negative 133. Okay, so make sure you understand this thing. Okay, you're going to have to remember that one, I think. All right, and the common difference. And what you're going to plug in. You're going to plug in, you're going to substitute what? This one and this one. But these others stay the same. All right? And we'll save this example here for in class. So that is it, I believe. And I will see you in class when I see you. Thanks a lot. Have a great day.